In this video, we're going to look at translating worded statements into algebra, into the language of algebra. This is arguably probably the most important step in solving any mathematical problem. Problems are normally presented or generally presented in worded form because we take it from the real world and then we convert it into a language, which is the language of algebra, to then be able to solve it or to be able to work with it and come up with a solution which can then be applied back into the real world. Okay, but the first thing is, if we start off with an English statement, is there a way we can convert that into an equivalent statement using algebra? Okay, so it's good to think of algebra really as a language, and it is a language. It's a set of symbols, it's a set of rules that we can put together to basically express in any form of logical statement or anything that involves some kind of logic and reasoning. Okay, let's have a look at some examples, and I've got a few here to look at. So this is where the literacy aspect is so important, okay? Because now what we're doing is we're turning English, okay, into maths. So first one, 2 more than a number, and we're going to use the pronumeral n to represent that unknown number. Okay, so we don't know what that number is. It doesn't really matter. All it does, it just represents some value, and that value could come from anywhere. So 2 more than a number, 2 more implies it's addition, okay, or a sum. So we could write the answer as n plus 2 or 2 plus n. It doesn't really matter, okay? So, or 2 plus n, both of those are correct, okay? 3 less than a number. Now, this one can be a little bit tricky because it's actually going to be written back to front. 3 less than a number. So in other words, less than means we're starting with the number. Less than means we're taking something away. We're taking 3 away. So in algebra, this statement here would be n minus 3. The product of a number and 5, the word product means multiplication. Okay, so it means n times 5. But rather than writing it as n times 5, there's a shorthand way of writing that, which is just 5n. We put the number first, and then we write the pronumeral, and we don't have to show the multiplication symbol. Okay. The quotient of a number and 4. So the word quotient means fraction or division. Okay, so fraction or, division, or we can represent it in fraction form. I'm going to represent it in fraction form. Okay, and notice that D and E almost look the same. There's a bit of a change to E, and we'll look at that change shortly. So quotient of a number and 4 is the same as saying n over 4 or n divided by 4. Okay, either one of those is fine. Okay, the quotient of 4 and a number. Notice the order. Okay, so in part D, the first thing quoted was the number and then the number 4. In part E, okay, we quote the number 4 first and then that number. So instead of it being n over 4, it's going to be 4 over n. Or we could write it as a division, 4 divided by n. Okay, let's have a look at some more examples. Okay. Double the sum of 7 and a number. Okay. The wording of this implies that the sum of 7 and a number must happen first, and then we're going to double that. Okay, so double means multiplying by 2. So the sum of 7 and a number, okay, so that's going to be 7 plus n. That's going to be in brackets. So we're going to do that first, and then we're going to double the expression in the brackets. Okay, so we could write it as 7 plus n times 2, or we could write it in a little bit sort of more shorthand way. So 2 outside of 7 plus n. Okay, or you can write n plus 7 with addition. Addition is one of those operations that you can sort of turn things around and flip things around and swap places, and it wouldn't make any difference to the answer. Division and subtraction, you've got to be very careful with the order. 6 less than triple a number. Okay, so again, what do we do first? 6 less than triple a number. So we're going to triple the number first, and then we're going to subtract 6. Okay, so tripling a number is the same as 3n. Okay, so in algebra, triple a number is 3n. if we're using n to represent that number. And then we're going to subtract 6 from that, 6 less. Okay, so it'll be 3n minus 6. Okay. Now again, I'm going to highlight the importance of order, especially when it comes to operations such as subtraction. Triple a number less than 6. So triple a number less than 6. So what are we starting off with first? 6 minus 3n. Okay, and again, something worded that's again slightly different again. Triple a number less 6. That's in fact the same as G. Worded differently, but translated exactly the same way. Triple a number less 6. It'll be 3n minus 6 again. So these three examples here, G, H, and I, really highlight the importance of order. And also, just by changing a word or a couple of words doesn't necessarily mean we're going to come up with a totally different algebraic statement or an algebraic expression when we're translating it into algebra. Okay, two more. The sum of twice a number squared and 1. Okay, twice a number squared. Well, let's start off with that first. And the last thing we're going to do is sum. Okay, so twice a number squared, 2n squared. Okay, and then we're going to sum that with the number 1. So that's the same as 2n squared plus 1. Decrease 10 by a number. Okay, the word decrease means subtraction. Again, to lower something. Okay, to take something away. Decrease 10 by a number. So starting off with 10, we're going to subtract a number. Okay, if I was to replace the word decrease with increase, what would that be? Okay, if decrease is subtraction, increase would be addition.